Good morning, everyone. It's a beautiful Sunday morning here in New Hampshire. I want to show you my pond and aquaponics system combination. The system is not completely set up, but it's getting close, and I was eager to share. So I'll start you off at the pump. This is the pond. It's about 2,500 gallons. It's meant to be a koi pond. I thought of maybe putting tilapia in here, but really decided the temperatures would remain too cold for good growth. It'll become a koi pond. Right now I have some pretty large goldfish in there, about 6 inches. That overwintered, actually. They started as 3-inch ones, and now they're 6-inch. You may occasionally catch a glimpse of them in here. I've also added some pond local flora from ponds, some cattails. Over here I have a lily pad growing. You, of course, place any plants in a pond in pots with soil. Right there you can see a sunfish, local sunfish in the pond. In addition, over here, it shows that I have water coming out from above. So let's follow that. And by the way, that pipe is temporary. It's going to be coming out the waterfall, which is under construction. Here's my pump. It's a regular sump pump system. There's my bottom drain. And I essentially used, I know there's fancier systems out there. I did my own do-it-yourself toilet bowl technology. Works great. I'm actually amazed how well it works. It stays extremely consistent. And that pumps the water up here. I have a natural slope on my property. If you do this on your property and you don't have a slope, of course you can, design some kind of system to have an uphill and a downhill version. So here's a 110-gallon tank. And I can give you more information on that later. But this tank is full of sand, so it's a gravity-fed sand filter. There's rocks in the bottom, and again I have schematics that I can post so you can understand more about this system. But the sump pump is just pushing that water up here, about 6 feet elevation. That gives me the gravity feed that I need to run the entire system. Over here is where my waterfall is going to be. I made an attempt last year, but have decided to redesign that. So I have a temporary shunt for the water to flow right down back into the pond. There's an overflow. Always build an overflow in the system. You never want siphoning in a system like this. Of course, you can create a siphon effect if you cap that, but that overflow is really important to manage all the water and notice that it's built level, so that the water level comes really close to the top, but not overflowing the actual tank. There's a water chimney. That's kind of a phrase I use for the pipe that goes down to the bottom of the sand filter system. And there's a rock layer, and again, a schematic, side view schematic will show you what is going on in this system here. There's also a bottom drain. Comes out right here into a hose connection. So coming out of that tank is a bottom drain. Really critical for New Hampshire, cold weather climate. I cannot let water freeze in this system over the winter. Over the winter, everything shuts down, and I have to drain this tank completely. Otherwise, it could crack from freezing. So let's check out the gardens. I have 2 raised beds. There, you can see they're relatively new planted. You will hear my chickens and ducks in the background, obviously very interested in what we're doing. These raised beds are 14 feet long by about 4 feet wide. And remember that hose that was coming out of the bottom of the sand filter? So filtered water from the pond. Right now it's just a hose laid out on the lawn. I eventually will bury that in irrigation tubing. This is a test just to make sure everything's working. So you can see that's just coming out right here. This is not pump-driven water. This is gravity-fed water coming from that elevation. So like I said, the whole system runs off one pump. As I lift this up, you can see as soon as I get above that elevation, it just stops. And as it comes down, try a test like this, right, just starts to bubble out once I get below that siphon line, gravity line. So what's going on here is these are wicking beds. So I've combined the technology of a wicking bed, you'll have to look that up, find out more information about a wicking bed, with an aquaponic situation where I want to push through water through my wicking bed. So there's a pipe system in here, and again, you need a side view schematic to understand what's going on in these beds. But you can see my water is coming in right here. It's essentially garden plumbing. Fills this bed. There's a rock layer on the bottom. The whole bed is really a swimming pool with a liner, essentially. So it does not go, this soil does not go down into the ground. It goes into the bed and it's in a plastic liner. The overflow for this water is here. Otherwise, of course, the bed would fill up. So you can see, this is the strange part of my garden. Everything looks pretty natural. All of a sudden you see plumbing coming out of the garden and then plumbing going into that bed. So that's interesting. Let's check it out. So what's happening here is I have, of course, a drain. For the winter time, I need to fully drain this out. And then right here, you may be able to catch a glimpse of this. There's an air hole to not allow any air blockage. And in there, that water actually is flowing in the direction around the pipe. But I had to put in this riser so that the water would be at the right level. And of course, all those things are measured. But I want the water to raise in this wicking bed up to the point where it's touching the bottom inch of the soil. So the top of the bed will remain dry, while underneath the water will flow just at the surface of, or the interface of the rocks. I have a 3/8 pea stone under there and the soil, and it'll keep the bottom of the soil moist, which will provide these plants with water. That's the idea of a wicking bed. This overflow goes underground. You can see I recently buried that pipe in here, and it comes up again here. It's just a couple inches below ground, just so I can bring my mower over here and people can walk without tripping on a pipe. Then it comes in and it's flowing nicely into here. I have it dispersing with both influent zones so that I can aerate the water with a bit of a natural bubbling action. The more air you get in the system, in this case, the better. You want heterotrophic bacteria doing their job, so that should be primarily an aerobic operation here. You don't want the whole system to go stagnant and anaerobic. And you can see the water level is just right. Why is that water level staying just right? Because on the outflow or the effluent of this second bed, you can see the two systems here. I have another gooseneck riser, and again there's a hole in the top so that I don't have an airlock, and that water rises up and will hit the right level so that it's at the right level in this bed and maintains that level continuously. Then I have a flow out, and so at the moment, because I'm not completed with construction, it's all tests, just making sure the whole system works, I have a flow out tube here, and that flow essentially matches the flow of the input that we saw on the first garden bed. As I pan across, you can see here's my other outflow pipe, and again, that one is going to come out the waterfall soon when I finish the construction, and this one is of course coming in from my bed. So I have full biological filtration now for my system. So in addition to providing these plants with the water they need, there also, in theory, should be sufficient nitrates, thanks to the nitrogen cycle processed by bacteria. I'll have nitrates, which are fertilizer, a key component of fertilizer, underneath, coming from the bottom of this bed. So I not only don't have to provide water on the surface once the vegetables are growing, but I also don't have to provide fertilizer. It's a good organic soil, and essentially the fish waste should provide sufficient nutrients. I learned from one person online, you absolutely do not want wicking beds or any type of aquaponic system to be essentially a sewage treatment plant for your fish. And so you have to have plenty of mechanical filtration, which I have over actually at the sump pump. I didn't show you all those details, but I have a mechanical filter. And then of course the water's going through a sand filter up above, and then eventually comes down, as you noticed, what should absolutely look like clear water. It's not perfectly clear. It's essentially filtered pond water. You can't drink this, but it's clean water for a garden. And that's what you want running underneath your beds. But of course, this water would have start with ammonia due to the fish waste. That ammonia is going to be converted into nitrites and then nitrates. And then the nitrates are what are going to enrich my garden.